Hey everybody, welcome to our final thing for Unit 9. Yay! We're going to be looking at similar solids. So you've gone through and found the area, surface area, and volume of everything. So now we're going to compare it like we did way back, I think it was Unit 5 when we did similar triangles. So it looks something similar to that. So let's think back to our Unit 5 when we talked about polygons that were similar to each other. What we saw, I don't know if you remember, that the ratio of the sides is going to be the same ratio for their perimeter or any two corresponding lengths. So when I talk about the ratio, I'm comparing some things that are in corresponding positions. So for example, 8 and 48 are in corresponding positions. So I can say that if I were to simplify that, it would have the ratio of 6 to 1 because 48 over 8 reduces to 6 over 1. And then that allowed us to then solve for other sides. So if I wanted to find that question mark, I would set it up as essentially 6 over 1 equals question mark over 6, and I would solve for that one. Now, the nice thing about that is the ratios for the side lengths is going to be the same thing for the ratio of the perimeters. So these ratios are all representing a one-dimensional piece of our shapes that we have. So this line here, this is one-dimensional. The perimeter is essentially all these lines added up, so it's one-dimensional. So all of their things here are going to have the exact same thing. Well, if I went through and I found the areas of this, the area of the big guy on the left, because this question mark is going to be a length of 36, would be 1,728, and the area of the smaller one is going to be 48. And if I took those two and I reduced it in my lovely calculator, or if you can go by hand, that's fine, I would find that this reduces to 36 over 1. Now there's a direct relationship between the ratio of the perimeters slash side lengths to the ratio of the areas. You see how to go from 6 to 36, we're essentially squaring it. Well, that's because area is two-dimensional. And so we can say that when we were coming up with the ratios of the areas, we would take these scale factors and square them. So take out your lovely foldable, turn it over, and you're going to write this theorem down on the back. Now leave a little bit of room because we're going to include some stuff about volume and surface area, but at the very top, write this down. So if two polygons are similar with the lengths of corresponding sides in the ratio of a to b, then the ratio of the areas is going to be a squared b squared. Now take a look at this real quick. What I want you to notice is that it's going to be 6 squared and 1 squared. This won't reduce any farther. Okay, that's why it's going to be directly related. So go ahead and take a moment and write this guy down. So side length slash perimeter is going to be a over b. And if I want to do anything with area, I would do a squared over b squared. All right, so let's do an example using that knowledge. So we have a large rectangular cooking pan is 15 inches long and 10 inches wide. And then we have a smaller one that is similar to that larger pan. The area of the smaller pan is 96 square units. So what we're going to do is find the width of the smaller pan. So I like to draw pictures in order to kind of get a good visual of what's going on. And so for my bigger one, I've got 10 inches long or 15 inches long and 10 inches wide. And then the other thing I know is the area of the smaller one. So I'm going to write that down. Now, when you're comparing these things, we need to have something that's in common. So whether it be the two lengths, the two widths, or the areas, we have to have something that's in common. So the first step here is to find the area of the bigger one. And I see the area is 150 inches squared. Now, what that's going to allow me to do is find the ratio to the areas, which would then lead to finding the ratio of the sides. Because if I'm looking for width, this is one-dimensional, so we need a and b. But what I have are two areas, which is a squared and b squared. So let's go ahead and compare those. I'm going to put the small on top and the large on the bottom. And so that means I'm going to do 96 over 150. Now, before you do anything, you need to reduce this fraction. Don't just jump into saying that 96 is a squared and 150 is b squared, because what's going to happen is you're going to get a bunch of decimals. So what you want to do is take this and reduce it as far as you can. So this reduces to 16 over 25. And what this represents is a squared over b squared. So what I need to find the width is a and b. And so what that means is I'm going to have to take the square root of 16 and 25 to find out what a and b are. So the square root of 16 and 25 is 4 over 5. So that means that's the ratio we're going to use. Now remember, small is on top. So when I'm finding the width is represented by x, and the corresponding position is 10. That's why I have x over 10. And then from here, I'm going to cross multiply. So I'm going to do 4 times 10 is 40, 5 times x is 5x, and then I'm going to divide by 5. So the width is 8. All right, let's do something similar to that. We have a fancy gazebo. It's a regular octagon. Each side of the floor is 8 feet, and the area is about 209 square feet. We're going to build a scale model because you like to do that, and we're going to do it such that the perimeter of the model one is 24 inches. So what we want to do is find the area of the floor model of that gazebo to the nearest tenth of a square inch. Okay, so let's again draw pictures. So I got my big one. I know that its length is 8 feet. And I know its area is 209 feet squared. Again, I'm getting myself a visual. Then I have a smaller one. And the only thing I know about that is that the perimeter is 24 inches. So as you can see, based upon this, and this, I don't have anything that's in common. So I have to think to myself, well, what can I find that would be in common? We have a couple of options here. The first thing is I'm noticing that I'm not going to be able to find the area because I don't know what the apothem is. But I can do either find the perimeter of the big guy or I can find the side length of the smaller one. And so what I've chosen to do so I can work with smaller numbers is I found the side length of one of these guys. And so since I'm looking at side length, I can come up with regular A over B. So what I'm seeing, so I use perimeter, sorry about that. So if I compared 64 over 24, I can use 8 over 3. You see how it doesn't really matter. Okay, so what I'm seeing here is that A over B is going to be 8 over 3. So this represents A over B, but I want to find area. I'm going to 2 dimensions. So what that means is I need to take this and I need to square it. So I'm going to work with 8 squared and 3 squared, which is 64 over 9. Now I realize that this 64 is the same number here, but these are 2 different types of ratios. This will not reduce down to 8 over 3. It's going to stay as 64 over 9. Now I'm giving you the 209 feet squared here, so that's what I'm going to use on top since the larger numbers are on top, which means the area of the smaller one is on the bottom. And I'm going to cross multiply like you've done in the past, and I find that the area is about 29 inches squared. All right, this is purely to find the ratio for surface area, and oh, just kidding. We want to know if these guys are similar. Okay, so we want to see, this is the one I'm given, and we want to determine which one of these two things here are similar to this one here. And so what we need to do is compare every single possible piece of these two rectangular prisms. So for example, I'm going to compare 4 over 8, I see that it reduces to 1/2. And in the same stuff, this 8 compares to this 4 compares to this 2, and this 2 compares to this 2. So what I'm seeing here is that 4 over 8 reduces to 1/2, 2 to 4 reduces to 1/2, and 2 to 2 reduces to 1 over 1. So since I don't have the same ratios of A to B here, 1/2, 1/2, and 1, therefore it means we don't have a similar polygon. So let's take a look at this one over here. I'm going to compare 4 to 6, 2 to 3, and 2 to 3. Well, 4 to 6 is 2/3, 2 over 3 is 2/3, and 2 over 3 is 2/3. Do you see how every single one of those ratios are the same? Therefore, this is the one that's similar to that one. Okay. So this is what I was talking about. Now you don't have to write this down. I just wanted to go over so you can kind of see the relationship between surface area and volume. Okay, so let's look at the smaller guy here. I'm going to find the surface area of that one. We see that the ratio is 2 to 3. This is from the previous example we just saw. So we know A over B is 2 to 3. So what I'm going to do is find the area of the base, which is 8. And the perimeter I see is 12 of the base. Again, I'm using the bottom here as the base. So when I find the surface area, it would be 2 times 8 plus 12 times the height here is 2. And the surface area is 40. Now I'm going to find the surface area of the bottom one. So the base is 6 times 3 or 18. The perimeter is going to be a total of 18 as well. And then the surface area would be 2 times 18 plus 18 times 3 for a total of 90. Okay, so now let's look at the two surface areas. Since these are similar measurements of similar solids, let's set up our ratio. I see I have 40 over 90, which reduces to 4 over 9. And what I'm noticing here is there is a very close relationship from 2 to 4 and 3 to 9. It's actually the same idea as when I'm just looking at area. So surface area and area also have a very similar ratio relationship. So if I know what the side length ratio is, I can square it, and that's going to give me the surface area one. Finally, let's look at the volume. Area of the base times the height. So again, the area of the base is 8. The height is 2. So when I multiply that, I get 16. When I do it for the other one, I end up with a volume of 54. So what I'm going to do is very similar to like I did with the area. I'm going to set up 16 over 54, and I'm going to reduce it. So I end up with 8 over 27. And I'm thinking to myself, these guys, I think also is really related to A over B. If surface area is squared, because this is dimensional, Volume. Volume is cubic units. So let's see, does this have a relationship to 2 using the fact that it's cubic? And the answer to that is yes. It specifically is 2 to the third power and 3 to the third power. So this is what you're going to do on the bottom. We have two similar solids. You can draw the picture if you want, but this is essentially what you need. If we have two similar solids, a scale factor of a to b, so that's comparing like the radius or the height or side length. Then the surface areas are going to be a squared b squared, and their volumes is going to be a cubed b cubed. And a good way to kind of keep this in mind is that this is one-dimensional, this is two-dimensional, and this is three-dimensional. All right. Let's use that knowledge now. We have the scale factor of 87 to 100. That means we're talking about the original scale factor, which is A to B. We want to find the surface area and volume of the larger can, given that we have the surface area and the volume of the smaller one. So let's start with our original knowledge. We know A over B is 87 over 100. Well, that's like a ratio of the radius or the height. And so what we want to do is find surface area. So I'm going to take those numbers and I'm going to square them because I need to use the ratio for surface area for us to find the surface area. Well, if I have the smaller one on top, that means I'm going to put 51.84 on top and S on the bottom, and I'm going to cross multiply and solve. For the volume one, I need to use a cubed and b cubed. So I'm going to take the 87 and cube it and the 100 and cube it, and then set up the ratio in a similar fashion. Okay, so again, if I'm solving anything with surface area, I use a squared b squared. If I do anything with volume, I use a cubed and b cubed. Again, I get that from the original 87 over 100, which is that scale factor. All right, these pyramids are similar. So there's a volume of 1,000 for the one on the left, and the volume of 216. So I want to find the scale factor. So whenever I say scale factor, I mean the original a over b. So I know that a cubed and b cubed is 216 over 1,000, but that might be able to reduce. So that's what I'm going to do first. Always reduce your fractions first. So I'm left with 27 over 125. Now I know that's a cubed and b cubed. I want to find a and b. So what we need to do is find the cubed root of 27 and the cube root of 125. If you don't know how to do that in your calculator, please let your teacher know and we will show you how to do so. But when I do that, the cube root of 27 is 3 and the cube root of 125 is 5. So now I can find the surface area ratio if I wanted to by squaring those numbers 3 and 5. All right, go ahead and get started on that practice. Let us know if you need some help. I know that we haven't gone through every single possible example that exists, but hopefully you have enough to get you started. All right, have a great day.